Hello everyone. For today's video tutorial, I'm going to start over a new sensor that is AD5252, and for that we have to log into the website that is controleverything.com, and here we have to search on for this sensor as you can see on my screen. And let's see what we got for this sensor. And here it is. It's a digital potentiometer. It's a 100 K, as you can see, 100,000. Now these are some more prominent features of this potentiometer, and the plus point is that you can purchase the sensor from here. Furthermore, I will be interfacing the potentiometer AD5252 with an Arduino Nano, and for that I will be going for the code, and resource tab is there, and when I click on the Arduino code sample, you can download the code as a zip file from here, and you can also have the code from github.com, and the official repository there is Control Everything Community. Now the next step is to have a look over the hardware connections we need for this setup, and let's have it. Now in the hardware connection setup part, the first thing we require is an Arduino Nano, which you are able to see on my screen. Next, we require an I2C Shield, just like this. Now it's available on the website controleverything.com, and the real reason we are using this shield is to make connections with other I2C devices a lot easier. So for that, gently place this Arduino Nano over the I2C Shield and make a connection like that. For the Powerup function, what do we require is a mini USB cable just like this, and gently insert it over here, the power jack. The next part is to bring our potentiometer, that is AD5252, and here it is, and this here is a connecting cable. Now make the connection among the connecting cable and the sensor, and make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and same rule has to be applied for the I2C Shield. Now we are done with the connections part. The next part is to provide the code. So let's have it. Well, let's have a look over the interfacing part, the section here, and the first step is to log in to github.com, and then we have to check for the repository. There is Control Everything Community. It's an official repository, and after that we have to find the sensor that is AD5252, and here it is. It's a digital potentiometer, and this is the Arduino code. But before that, let's have a look over the Arduino instructions. As you can see on my screen, we have to follow it carefully, and first of all we have to download and install Arduino software ID on our local machine, and this link Arduino.cc is the official link from where we have to download the software, and it will run on Windows, Mac or Linux operating system as you wish. After that, we have to download or git pull the code, and we have to double click onto the code to run the code, and the last step is to compile and upload the code on the Arduino IDE, as you can see, and we can have the output onto the serial monitor. So we have these instructions. You need to carefully install this, and after that we have to get back to the Arduino code, and it says that it's a .ino extension file. Now as you see, we have first of all included wire.h library onto the code, and we have defined the address of the sensor, that is 0x2c. Now in the void setup function, we have initialized I2C communication as master and serial communication with set baud rate equal to 9600. And in the writing section part, we are going to send the instruction for potential POT channel 0, and it's 0x01, and we are going to send the input resistance value, that is 0x80. After that, we are going to send, on the writing section part, we are going to send the instruction for potentiometer channel 1, and it's 0x03, and the input resistance value, that is 0x80. This is the end of writing section. Now we are going for the reading section. As you can see on my screen, in the void loop function, we are going to select the data register, that is 0x01, and from here we are requesting 1 byte of data, and then we have the conversion of this. As you can see, is the float resistance value. It's a variable, and we have used the formula described clearly in the data sheet of AD5252. Then again in the second reading section, we are going to select the data register, that is 0x03, and from here same procedure has to be followed, requesting reading and conversion of the data. After that, at the very end, we have the output data to be printed onto the serial monitor, which you can see as the resistance of channel 0 along with the channel 1. So this is how this code looks like. Now let's see how it works. Now coming to the working session, and in this part we need to copy the entire code of the Arduino, and now we have to open up the terminal for the Arduino, and in this part we need to create a new file, as you are able to see on my screen, and we have to paste the entire code there, and it will be AD5252 for the reference. And then I have to verify and compile the sketch onto the screen. It's compiling done, and then we have to upload the code. It's being uploaded. It's done uploaded. Now we have to check for the output onto the screen, and as I open the screen, the serial monitor, we can have the resistance value for channel 0 and channel 1, and it is 5 kilo ohm. It's the value across the terminals W and A. When I use a digital multimeter and check the terminals W and A for both the channels, the same value is reflected onto the screen, which means the sensor is working as per we desire. Now let's have a look over the applications and some of the benefits regarding this part. The AD5252 is a dual channel I2C non-volatile memory digital control potentiometer with 256 positions. This device performs the same electronic adjustment functions as mechanical potentiometers, trimmers, and variable resistors. The part's versatile programmability allows multiple modes of operation, including reading, writing access in the RD, AC, and EE MEM registers, increment, decrement of resistance, resistance changes in plus minus 6 dB scales, wiper setting readback, and extra EE MEM for storing user-defined information. Due to these features, is really applicable for a lot of applications like mechanical potentiometer replacement, LCD panel VCOM adjustment, white LED brightness adjustment, RF base station power amp bias control, programmable voltage to current conversion, and a lot more to mention. Well, you can have this sensor and you can purchase it from controleverything.com, and you can get the code from resource tab. From this site, you can download the code as zip file. Also, you can get the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubts regarding any part of this sensor or video, you can have your queries on controleverything.com, and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com, and to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.